Good evening to one and all. Myself Nagababu, working as Assistant Professor in Department of IT. It gives me great pleasure to welcome you all to the 5th day of our faculty development program on unlocking innovations with blockchain and generative AI. Over the past few days, we have explored a plethora of transformative technologies that are reshaping industries, education, and the future of work. Today, we have two exceptional sessions that will deepen our understanding of blockchain and its integration with AI. Our first session focuses on building smart contracts in Ethereum blockchain led by Dr. Kalavathi. In our second session, we will delve into AI governance and data integrity using blockchain, a critical topic with Mr. Aravind Organti, Vice President of Information Data Systems, who brings vast expertise in data management and blockchain-driven solutions. Let us embark on today's enriching journey. Now it's my pleasure to invite Dr. Kalavathi, madam, to take our session on building smart contracts. Over to you, madam.
Thank you, sir.
Yes, madam.
Good evening, everyone. I welcome you all to the first session of 5th day. In the first session, we have explored on blockchain technology. And there we learned basics of blockchain. What is a blockchain? And what are the different ways of implementing it? Who has coined the term and who have implemented? What is the basic idea behind blockchain technology? And what are the different types of blockchains? Under that, we have covered Bitcoin blockchain. So we have seen what is the value of 1 BTC in Indian rupees also. And Bitcoin is only targeted for fintech space, that is only for cryptocurrency and financial applications. And we have the second type of blockchain, which is Ethereum. This is for both cryptocurrencies, means for fintech space and for web applications also. You can develop all your web applications, you can develop all the decentralized applications using Ethereum blockchain. And this Ethereum blockchain, here we learn, first of all, what is Ethereum and what is a smart contract, what is a DApp. DApp means decentralized applications. And what is your EVM and gas? What is a decentralized autonomous organizations? Of course, there are many other topics like hard and soft forking, DAO attacks, ICO and altcoins. We cover only the basics of Ethereum blockchain and this 1.5 hour session. Now, coming to the Ethereum blockchain, as we have known already, as we have studied, as we have learned already, Bitcoin was coined by a group of people, that is Satoshi Nakamoto, whereas Ethereum blockchain, it was coined by Ethereum blockchain was coined by, or it was implemented and designed by a 14-year boy. See here, you can see a 14-year boy. He has developed an Ethereum blockchain. His name is Vitalik Buterin. And here is the logo of your Ethereum blockchain. 1 minute. Sorry. So the person by name Vitalik Buterin, he has designed Ethereum blockchain. This is the logo of your Ethereum blockchain, where he has 1 minute. Here he has developed Ethereum blockchain, and this is the logo of your Ethereum blockchain. Here we learn different protocols. Like we have seen 3 different types of blockchain protocols. One is waves, that is, the most popular 2 technologies are Bitcoin and Ethereum. We covered little bit on Bitcoin, and the second one is Ethereum. So now we are discussing on Ethereum protocol. Now, coming to the technology behind Bitcoin and Ethereum, these are the logos of your Bitcoin and Ethereum. Of course, both are open source blockchain based platforms. Now, here also we represent each and every system as an Ethereum node. We represent, like we have represented in Bitcoin blockchain. We connect all the different nodes together. Like if there are n number of nodes, we connect all the nodes together. And here we represent these nodes as full node, light node, and archive node. Full node, light node, and archive node. What we do here, what is the different types of these nodes? And for example, if it is a full node, here it maintains a copy of the entire blockchain, and it verifies and validates each and every block, whatever you have created. That means this node is a complete blockchain node where it stores the entire ledger, entire history of your Ethereum blockchain. And this node can be used to verify and validate all the transactions, whatever happening in this particular Ethereum blockchain. Whereas coming to the light node, it stores only the block header, means this block, what is the block number, what is the size of block, how many transactions happened in this particular block. So that means it is somewhat low capacity devices. Suppose if your device doesn't have that much capacity, you can keep your node as a light node. And the last one is archive node. It requires terabytes of disk space, where instead of storing the entire blockchain, a copy of the entire blockchain, it works like a full node, and it also have a copy of it also have an archive of the entire historical data, means the other blockchains and previous blocks information also will be stored in archive nodes. Now, here, as we already know, a blockchain consists of, it is targeted for cryptocurrencies, and it is here particularly Ethereum, it also focus on web applications. For example, coming to your Ethereum accounts, here we use these Ethereum accounts to store your ethers. Here we represent the cryptocurrency as ethers. In short, we call them as ETH. So to store your data, to send your ethers, to receive ethers from the receivers, you can use these accounts. Of course, here we have 2 types of accounts. One is externally owned account, and the other one is contract owned account. Externally owned account means the wallet which has been created by you, and here you have to get your wallet address. This is the wallet which have been created by you. And the other one is contract account, which is created by your smart contract automatically. This is created by your smart contract automatically. Now let us see. Suppose if it is an externally owned account, this account will have, this wallet will have a public key and a private key. Here, public key means it is represented in hexadecimal notation, and this itself is also known as the wallet address. This is your wallet address. If you send this public key, or if you share this wallet address to anyone, using this wallet address, you can receive some amount of money from others. That means like you are sharing your QR code, like you are sharing your phone number to transfer money using PhonePe or Google Pay. By sharing your account number, you can get the money. For example, this is your private key, which is secret. This is used to connect to your blockchain, to connect to your wallet. So here we use your Ethereum blockchain. Finally, we use our Ethereum blockchains here to send the transactions, to receive transactions, means to implement your functions and to write your smart contract. Theoretically, if I say more about this Ethereum blockchain, you may not understand anything. While executing some programs, I will explain you how do we apply transactions and how do we write a smart contract. So now coming to the contract account, as I have already explained, contract account, it is created by your code, means by your smart contract. Here we just represent, here we write a program. We call the program as a contract. Don't confuse with the word contract. Here our program name itself is a contract. Like we start in Java with a keyword by name class. Here I start with a name by contract. Now, here is a smart contract. For example, here the smart contract is, for example, I want to deliver some goods. Suppose if I am delivering some ice cream packets, or if I am delivering some fish or meat, something else, they should be preserved in certain temperature. And if if it is less than the temperature or greater than that particular specified temperature, your item will be spoiled. Therefore, you should implement to deliver the goods safely. If it is within the limits of the temperature, then only our customer receives. Otherwise, our customer rejects the item and he will again revert back to you. That is why what you need to write here, you need to implement a code. Suppose you need to write some conditions. What should be your temperature? What shall I do if it is greater than or if it is less than the temperature? What shall I do? You have to write the entire thing. That is known as a business logic. Here just we use a different terms. That is the difference. Business logic. That means the logic you are implementing, it is a business logic. And before going to the actual smart contract, let us see what is the difference between your externally owned account and contract account. Both of them, externally owned account, it requires a private key, whereas the contract, the account created by your smart contract, it requires only public, it neither requires private or public key. Whereas it is, since the externally owned account lies in your, it exists in your wallet. Therefore, it is controlled by the human, where it is controlled by your contract code. Even if I say gas, you may not understand anything. So we move further. There you understand what is a gas and what is that unique address, what is your ETH balance also. So smart contract means it is simple. It is a program. It is a software or program written. It is a simple program written by using some programming language. Which this programming language, it should support your Ethereum blockchain. So here you can use here there are several supported programming languages. In this particular session, we focus on Solidity programming language. Of course, nowadays there are n number of libraries even in Java, and you can also implement using your Python. But this is a full-fledged blockchain supported programming language. And you may also use Golang. This is your Golang programming language. You can also go for Viper. So these are the different programming languages using which you can write your smart contract. Now, to implement smart contract, we have seen two blockchains now. One is your Bitcoin and the other one is Ethereum blockchain. Whereas Bitcoin only targets fintech space, but whereas Ethereum, it focus on financial transactions means cryptocurrencies, and also on web applications. And here Bitcoin script, it is a scripting language by using which a Bitcoin blockchain was developed. It is not Turing complete. It is Turing incomplete programming language. But whereas Solidity, it is Turing complete programming language where you can use all controls, conditional statements, and it is a perfect Turing complete programming language. Now, whenever you execute your smart contract, n number of blocks will be created with different types of nonce value, timestamp value, and previous hash value. I will show you all those blocks also while executing the program. Now, suppose we have seen so far we have developed applications in a client server architecture. In a client server architecture, what we do? We store our web application only at server. We store our web application only at the server node. But here we store our smart contract at each and every node. You forget about your client server architecture. In the coming future, there won't be any client server. All the systems are full-fledged decentralized. That means each and every node has a copy of your entire application. That means your application is going to be stored at each and every device. Now, coming to the smart contract, it is it is a contract, it is a program where it stores all the, transactions. It stores each and every node transactions. Coming to the centralized applications, you see here, we store only the database or application at the server node only. We don't store at client devices. Here we don't store the application. This is what we have worked so far. But coming to the decentralized applications, we store our database at all the nodes. So this is what your decentralized applications, which is in short, is known as a DApp. DApp means decentralized application. Now, whenever you write a program, whenever you write some web application, what you need to do? You should work with backend and you should work with your front end also. Here also, you might have seen a .NET full stack, Java full stack. Here also we have blockchain full stack. Here the backend is your Solidity programming language, where we write the entire business logic. Don't confuse with the word business logic, where we write the entire program with a different number of functions. And here we go for front end. Coming to the front end, we use the same technologies like we have JavaScript, React.js, AngularJS, Node.js. We use all these technologies, JavaScript, React.js, Angular, HTML. We use all these front-end concepts. And when you combine your back-end and front-end, you will get one DApp. You will get one decentralized application. To execute this decentralized application, like we use Java Web Server, or servlets, or Spring Boot, or Hibernate, whatever it is. Here also we have n number of environments and frameworks to execute your web applications. So we execute them in a decentralized network. For example, let us go through some decentralized applications which have been developed so far. The very first one is the centralized client server application is Google. That is Google search engine. Whereas here under blockchain technology, the decentralized application is pre-search. Whereas here, LBRY, this is a social media network. It works like your Twitter. And coming to the video platform, here you have YouTube. And here I have D.Tube, that is DTube. So let's see, I will just show you the websites also. And then you can understand the difference between the normal search engines and these blockchain search engines. First, I will show you. 1 minute. 1 minute, something happened to my system. Okay, I will go through tab. See here. One minute. Something happened to my system. 1 minute. Yeah, now it is okay. See, here we go. The first one is d.tube. I'll copy the website link. Suppose if you previously, before 6 months, DTube is working, but I don't know. The DTube is not working nowadays. Therefore, let's go to the DTube, another application, dtube.uminate.fun. Once you go to this particular YouTube kind of application, you can search or you can see any kind of videos here. Suppose if I search for some blockchain technology, you see here, if I search for some blockchain technology, generally, whenever I type, it displays the n number of videos on blockchain. But here I am giving some hint. Blockchain developer 81, blockchain.app, blockchain x12, root app blockchain, ruta blockchain, blockchain BI. These are all the nodes, or these are all the people who have this kind of blockchain information. That means directly you can get the data from this particular blockchain developer 81. So this is the node. That means in coming future, you can suppose if you have your videos, you can run your videos, you can run your YouTube videos from your system itself. You need not post in YouTube. You can gain your own money, but you cannot see any video. But nowadays, we are freely watching all YouTube videos, Facebook contents, and everything. But yeah, you are spending you are spending a lot of time on YouTube. You are wasting your time, and you are spending so much amount of money on internet also. But you don't gain anything. Finally, our health will be upset. Therefore, here in once the decentralized applications came, if you want to view any video, you should purchase. Then only you can view. Suppose if you develop any content video, you will get money. None of YouTube or none of some other search engine or none of other servers or companies, they are going to get money. They don't get money. You are the one. You are the creator of this content. You are the one who is going to get the money. Suppose if I share your content for sharing purpose, I am also getting some amount of money. For example, if I go to presearch.io, most of the blockchain applications, they start with IO. And this is presearch.io search engine. Here you can run your system as you know. Then you will get some amount of money per month. That is for running your node as a blockchain network. For running your system, your laptop as a node in blockchain network, you can earn money. But there are a number of policies you should go through very carefully. Let's go for Tribe Research. This is your search engine. And here, so whatever you want, you can type the content here. So like you have, like we have our Google search engine. Here also you will be getting a number of links on blockchain technology. You can get the entire content. And now this is all about your different web applications. Now let's move to the next concept. Like when we compare our old centralized applications and decentralized applications, why I'm saying here that centralized applications as not trustworthy, Why? Because there, only once, YouTube organization or Facebook organization or some Google, they are the entire whole and soul person. I should believe them. I should trust them. If they are not trustworthy, if they compromise with some others, there won't be any there won't be any privacy to your data. Another one is a decentralized applications. There are entirely trustworthy. Coming to the disadvantage, whereas in centralized applications, you have some kind of censorship. Here we don't have any censorship in decentralized applications. Whereas in centralized applications, you need to pay, but in decentralized applications, you will be getting the money. And sometimes in centralized applications, since you are storing the entire data in a single server or multiple servers at different locations, per country or some per continent, we may have n number of multiple servers. If they are go down or if someone hacks them, then your server may go down. But whereas here, since your application is at n number of terminals, in thousands of terminals, in lakhs of blockchain nodes, your applications may not, your web application, it may not go down. Even if for hacking also, it is highly impossible for a single person or for a group of persons to hack all the nodes at a time. Therefore, data permanence is there. So this is what about your decentralized applications. Now, to execute these applications, I should have, suppose to execute your Java programs, to execute your programs written in Java, you should have Java virtual machine. Similarly, to execute my decentralized applications or web applications, in web, what I want to say is in dApps, you should have both front end and back end. So back end is your solidity. To execute your programs, you should have Ethereum virtual machine, which is in short EVM. We use it to call this Ethereum virtual machine as EVM. This is like our JVM. You know the purpose of JVM and EVM also. Now let's see here. Through these diagrams, I want to say it is highly impossible to hack all the nodes at a time. So now this is your Ethereum virtual machine. And suppose to run your machine or to run your car, automobile, what we do? We fill some amount of fuel. It may be your petrol, diesel, or it may be your gas also. Here also, to run your virtual machine, to run your Ethereum virtual machine, to execute your programs, you should pay, or you should pay for fuel. You should pay for gas. You may be wondered why we need to pay gas or why we need to spend some amount of money to execute programs. You may not have, we have not come across to such kind of paying some amount of money to execute programs or to execute web applications. But here in blockchain applications, it is the internet of value, internet of money. So to execute your smart programs, you need to pay some amount of money using your crypto wallets. But here, don't worry, while executing the programs, we use fake ethers and fake accounts. We work on test networks only. So using this fuel, you can run your smart contract. Like you are running your automobile, like you are running your engine, you can run your smart contract using some amount of fuel or gas. Now, suppose how the amount of money will be calculated. For example, in some particular program, if I want to calculate some A into B minus C equal to some D. Suppose if this is my instruction. To execute this instruction, so I need to calculate, how many variables are there? I have altogether 4 variables. I have 4 variables. These variables are, I should know whether they are global variables or local variables. Here we use it to call the global variable as state variable and the local variable as local variable only. Now, see here to implement this, to execute this instruction, coming to the, here you have a table, according to the Badmas rule, For multiplication, we require 5 gas. To execute your subtraction, we require 3. And for equal to symbol, this is also some kind of assignment operator. You are assigning some value to some particular variable. This is also some sort of work. Therefore, it also requires 3. Depending on the hierarchy, we use it to assign some amount of gas. Now, altogether, what is here? 11 gas. Don't worry. It means 11 ethers. It is not 11 ethers. It is just 11 gas. Now, see, how do we calculate this gas? For example, to find out the gas price, always we represent gas in terms of GVs. GVs means gigaVs. 1 gigaV equal to 10 to the power 9, 10 to the power minus 9 ethers, ETH. 1 gigaV equal to, 1 GV equal to 10 to the power minus 9 ethers. So let's see how do we calculate. The gas price means 1 gas price equal to 1000 GVs. Here, see the denominations of ether. I didn't show what is the price value of your ether. You can see the price value of your ether here. For example, in the last class, we have seen 1 BTC equal to 95 lakhs something. And here 1 ETH to INR. See the price value here. 1 ETH is equal to nearly 3,25,587.32. And here itself you can see the Ethereum blockchain also. Once you go to etherscan.io, this is your Ethereum blockchain. Here also, like our Bitcoin blockchain, you can see all the latest blocks and latest transactions. If you go to any one of these transactions, here you can see all the details. What is the timestamp? What is the block height? And who is sending how much amount of money? Who is the sender and who is the receiver? You can find each and everything here in this etherscan.io. Now let's move to the denominations of ether. And these are the exact denominations: V, Kiwi, Ada, femtoether, megaVs, babes, picoether and all. Out of which these I have taken only few. See here V. 1 V equal to number of V's are 1. Kilo V's means Babbage. Everyone knows about Charles Babbage. Who is Charles Babbage? Father of computers. It is 1000 V's. Mega V's are known as Lovelace. Who is Lovelace? She is the first programmer in the world by name Madam Ada Lovelace. In those days, sir and madam are the great awards given to the people who have contributed in particular field. But nowadays we use it to call madam and sir for everyone. And this is Megavi Lovelace, which is 1 e power 6 V's. Another one is Shannon. And you might be wondering, who is this Shannon? Shannon is a linguistic person, famous linguistic person, who has developed the first artificial intelligence learning language model, that is AI-LLM. So they have contributed, and they have contributed his name to the gigaVs. Next we have teraVs, TWEI, who is, and the name is alternative, alias name is Szabo. Szabo means he is Nick Szabo, famous cryptographer who has, for his research in smart contract and digital currency, teraVs are known as Szabos. Next we have petaVs, Finney. Finney means here Hal Finney, H-A-L Hal. Hal Finney, he is the first person who has received first Bitcoin to his wallet. So he is a Bitcoin. He is also one of the Bitcoin contributor. And the last one is Buterin. This is 1 ether. See how many zeros are there? 9, 12, 18 V's. Means we have 18 zeros. That is 1 e power 18 V's is 1 ether. 1 ether is Buterin. Why? Because Vitalik Buterin is the founder of blockchain network. Therefore, he has assigned his own name to the ether. Now let's come to the gas price calculations. To calculate your gas price, here we need, suppose here we require, the gas price per unit is 100 GVs. Per transaction, you need to pay 21,000 units. Total fee that you need to pay to execute the program is 21,000 into number of transactions that you require, that is 100 GVs. 21,000 into 100. In our previous transaction, we require, see here, how much amount we have identified here. This is something like 11 gas. So here you can use 21,000 into, instead of 100, you can write 11. Then you will get the amount of price that you need to pay. Though it is 21 lakhs here, coming to the giveaways, it becomes 0.0021 ethers. It is the very least denomination. So now let's move to what is a decentralized autonomous organization. We have several hierarchical organizations and we have different kinds of roles. For example, even if you take our educational organization also, we'll be having principal. We treat him as a chief superintendent of examinations, and we have controller of examinations. We have deputy controller of examinations. Under that, we have a number of HODs and deans, and we have a number of teachers. And so when we go to student automation, suppose who will be given permission to add marks to a student? Only subject teacher can add the marks. Only teacher can add the marks. That mark should not be edited by HOD or dean or controller of examinations or by any chief superintendent. So teacher is the whole and sole person. So we develop only one application. That application, suppose now in normal web application, whenever we develop, what we do? We write from user side. We develop application from user side and admin side. See how much duplicacy is there. You have redundancy. You are creating the same page from user side and from admin side. Here you need not have that kind of redundancy. You can develop a single application, and suppose we have, let us see, add marks, update marks, delete marks, and view marks. View marks can be viewed by everyone, but these three things can be edited by subject teacher or class teacher. This is how you can write this function in a single program. This function can be executed by teacher. This function can be executed by principal. This function can be executed by COE. This function can be executed by everyone. Then you need not specify anything. For these three things, we should write some code. And this is how we implement separate applications for each and everything. Now let's quickly go into our Solidity applications. For example, to develop such kind of a blockchain web application, we need, these are the supporting programming languages as I have explained earlier: Solidity, Viper, and Rust. Next, we have different IDEs. Like we have Eclipse and a number of IDEs. Here we have Remix IDE, Ethfidel IDE, Ethcode. The most popular one is Remix IDE. This is a web-based browser-based application. Like we implement our programs in Colabs. Here also you can develop all your applications in the browser itself. Now coming to the frameworks, like we have Truffle, Hardhat, and Embark. That means instead of IDEs, if you want to develop your applications using some tools, using your local area command prompt, then you need to go for these tools: Truffle, Hardhat, and Embark. Now, another one is APIs and SDKs, application programming interface and software development kits. Before going to this, let us explore these things. And like whenever you need to develop web application, we should go for Java Web Server or Apache Tomcat. We go for some local servers. First, we test our application on the local server. Similarly, here we have a local server by name Ganashi. This is a local web server. And we have some public test networks. Means previously I have informed you to execute your applications, you should have some blockchain networks, you should pay some amount of money. How do you pay? Using these test networks. Robston, Rinkibi, Gorley, Sepolia. When I learned in the year 2021, there I worked with Robston and Rinkibi. And when I taught this subject for the first batch, then we used Gorley. And these are all outdated. Now we have Sepolia test network. And coming to the mainnets, here we have Ethereum, Polygon, and Binance. These are the main networks. To work with these main networks, we need to pay we need to work with real cryptocurrency. But here we use some test currency or fake ethers. And these are the APIs and SDKs. Suppose if you want to execute your applications for each and every one, and in the web servers, in the web or in the internet, to deploy them in the internet, we use Alchemy, NFT API, Third Web SDK, Moralis API, and SDKs. So these are the n number of tools we use. So these are the links for implementing. Of course, I'm not going to concentrate on these tools. First, we learn with a browser-based IDE, that is Remix. Now let's quickly go to our programming language. Here, Solidity, it is a open source, high-level, object-oriented programming language. And it is inspired with your C++, JavaScript, Python, C, and n number of programs. By using all these programs, by taking the advantages and by taking the good features of all these programs, and even Java also, they have developed Solidity programming language. And this language targets, it works, the programs works in Ethereum virtual machines. And these programs are known as self-executable smart contracts. Why I'm saying that these are self-executable programs? While executing a program, you can easily understand about self-execution. Now let's quickly move to the compiler. For example, to execute any program, first we need to compile. Here we have two flavors of compilers, Solc-C and Solc and Solc-JS. Solc compiler is written using C++ programming language, whereas Solc-JS compiler was written in Node.js using Node.js library. Like for example, not only Solidity, suppose Java compiler. We have two different types of JVM, Sun-based JVM and IBM-based JVM. To execute this compiler was designed using C programming language, and this compiler was designed using by Smalltalk. Similarly, your C programming language or Python. The interpreter was written in C. So this is how, and C++ compiler, it was written in C programming language. To implement compilers, we should have some other, we should take the help of another programming language using here Solc, Solc-JS, out of which we work with Solc compiler right now. And a truffle, it is a truffle is a truffle suite. We have under tools we have discussed now. By implementing your truffle suite, you can deploy your applications, you can test your applications. This is a tool which is used in which is used in industries, and supposed to execute your programs in command prompt, you need to use this particular tool. Ganashi is a local blockchain. It is like your Apache Tomcat, or it is like your Java web server. And this blockchain simulator, it deploys the applications in your local system. And this simulator, it contains a wallet also. It contains a wallet. This wallet is this wallet has some fake ethers. You need not create a wallet. It has already a wallet with 10 accounts or a wallet with 100 accounts or 200 accounts, you can customize this particular Ganache blockchain. Next one is MetaMask. It is a wallet which you need to download. Which you need to download or you need to add as a browser extension. Using which you can, you can connect your IDE to these wallets and you can execute your programs. Now, the first web-based, browser which we work now is Remix. For this, you need to go to particular website by name remix.ethereum.org. remix.ethereum.org. So this is the website name using which we develop all our applications. To implement your web application front end, we go to Web3 JavaScript and see here, we learn all these things. What is a smart contract? What is a remix ID? And how do we define the smart contract applications? What are the different number of variables? And what are the different number of conditional statements? How do we write functions? How do we write structures? Here, of course, here we have structures also. That is why we have, that is why here I represented Solidity was developed with the help of with the influence of C programming language and C++ also. Here we have structures concept also. And of course, since it is object-oriented programming language, we have all the inheritance concepts, polymorphism, and we have method overloading and all the concepts are there. Data abstraction. Now, smart contract, it is a simple program stored in our blockchain. As I explained earlier, it is a high-level statically typed programming language and it is case sensitive. Suppose when you execute your file, always the file name extension is name.sol. You should give. When you execute your program, it gives two flavors of the files. One is your Solidity compiler gives two kinds of files by name ABI and bytecode. For example, we write Java program using .java extension. Once you compile this program, you will get some class file, .class file. You will get one, but here you will be getting two different files, ABI and bytecode. Let's see what is this. ABI is your first thing and bytecode is the second file which is going to be generated once you compile. This bytecode is going to be executed on Ethereum blockchain, that is on EVM. As we have studied so far, JVM runs the bytecode. Here EVM runs your bytecode. But we have never seen how a bytecode looks like in Java programming language. But here we see, we go to, we directly work on some, okay. Your bytecode is immutable and it works as a bridge. Out of these two files, one works as a bridge between like your ABI. It works as a bridge between front end and back end. Sorry, back end and front end. First we develop back end now, then we go for front end. So it works like a bridge between your back end and front end. This is abstract binary interface. Abstract binary interface. It creates it is written in JSON notation, Java script object notation. So it runs in it, it will be in JSON format. Now, the first line of your Solidity program should be SPDX license identifier, MIT, GPU, or unlicensed. You can write anything. But this is the, even though it is a comment statement, even though it is a comment line statement, you should write compulsorily, otherwise you will get some warning. So SPDX license identifier MIT or SPDX license identifier unlicensed. Here it is. This is also a capital letter. Now let's move to the next step. Like we write after your SPDX statement, SPDX license statement, here I should write a pragma keyword. Pragma, P is a small letter only. Pragma solidity. This is the name of the programming language. Here you can run your version. Suppose you have so many versions in Java programming language, no? There we don't specify, but here, since they are still developing the programming language, you should write which version you are using. So here you have several different types of syntaxes to define your version. Pragma solidity 0.8.14 or greater than or equal to 0. That means it runs in between 0.5, 0.5.0 to 0.9.0. And between these versions, it works. Next version 7, 8 version 0.8.9, 8.14 also. Or simply you can write Pragma ABI coder V1, Pragma ABI coder V2. Out of which the most two popular statements are these two. And here I use the first one, that is Pragma solidity 0.8.14. That is the cap symbol you should use compulsorily. Next one is, if you like in Java, we have here also import statements. Sorry, here all import statements are with small letter only. Import file name or import file name as some symbol name or import star as symbol name from file name. You can use any of these statements. And we have comment line, single line comment and multiple line comments or NAT specific comments which are used before. NAT specific NAT-spec comments means these are used before your functions or statements or instructions wherever you write. Now, next one is structure of the contract. A contract contains means your contract contains n number of state variables, n number of functions, function modifiers, events, error. Here also we have error handling concept. Of course, we don't go for advanced solidity. Struct types, enum types, and we have n number of libraries and interfaces also. That means this is a structure of your contract. It looks like this. So contract name. First I should write a keyword contract. C is a small letter only. Contract, name of the contract, and here you have n number of statements, state variables. Here, whenever I write state variable, don't confuse with the word. This is like our global variable. This is our global variable. Now, here you have, let's see what is a state variable and what is a global variable. How do we access them one by one? But before going to them, I'll just introduce some data types, and then we directly go to the IDE, and there I will try to implement these programs. See here, we have different variables like value types, and then we have complex types. Here we have signed integers, unsigned integers, Boolean, addresses, enum, bytes. These are simple data types or primitive data types, whatsoever you call. And here, whenever I talk about signed integers, it is int. Whenever I talk about unsigned integer, this is UINT, which is not there in the other programming languages. Unsigned integers. Signed integer accepts both positive and negative values. Then why do we need to go for unsigned integer? For example, if I want to define age starts from 1 year to n number 100 or something else. It won't be negative, no? Like -1, -2, -4, -5. It won't be negative. Then why should I go for signed integers? I can use unsigned integer, no? So that is why wherever you work with positive numbers, you can go ahead with positive numbers to avoid all kind of errors. That is UINT, Boolean, address, and enums. And the other reference types are fixed size arrays, Dynamic size arrays, array members, byte arrays, string arrays, structs, and mapping also. See here, do we have any character variable char? This programming language doesn't have any character variable. Of course, instead of character variable, by using bytes itself, I can go for bytes represents hexadecimal information. Even you can write bytes b equal to a, or bytes b equal to some ABC. You can also define a string. So bytes is a primitive data type, whereas arrays, strings, byte arrays, even if it is byte arrays, string arrays, all kind of arrays comes under reference types, structures, mapping, they also come under reference data types. Now let's go to the different denomination, the different ranges of int data type, signed integer, int 8, minus 128 to 127. See, in the other programming languages, even in Java also, if I say int, it gives 4 bytes memory. It allocates 4 byte memory space. Suppose if I want to store only int a equal to some 1, 2, or some 256. How much amount of memory space I require? I require only 1 byte. Then why should I allocate, why should I waste 3 bytes of memory space? So to optimize your space, you can have int 8, int 16, int 32, int 24. This is how you have n number of integer variables. Now coming to the unsigned integer, here also you have even for unsigned integers also you have uint 8, uint 16, uint 24, 32, 40, and so on up to 256. uint 256, it allocates 256 bytes of memory. You need not go for int, long int, and integer class. Of course, in Java, it doesn't support, when we go to the integer class, there we have a big integer concept. Big integer bi is equal to new big integer of. And we have another type of variable in Java also, that is atomic integer. Atomic integer. To calculate for physical and astronomical calculation, scientific purpose, they use this atomic integer concept. Whereas big integer is mainly used for mathematical and cryptography calculations. Data integrity calculations. For all hash algorithms, we use this kind of big integer concept. So here, you need not go for that many types of integers. Simply, you can go for uint 8, uint 16. This is how you can have your unsigned integers. Next, you have Boolean for inequality, equality, logical negotiation, conjunction, and disjunction, and all. You see here, we have address. And you may get a doubt, why do we need a field by name address? Here, since to execute our programs, we need to pay some amount of fake currency. I have already explained you, like in decentralized applications, suppose first function 1 can be executed by controller of examinations. Function 2 can be executed by HOD. Function 3, it can be executed by only class teacher or subject teacher. Function 4, anyone. Then how should I recognize all these people? I assign some address which is in hexadecimal notation. What is this address? This is your wallet address. This is your cryptocurrency wallet address. So by using this address, each person will be given a public and a private key, and this public is known as your wallet address. This is how, since it is in hexadecimal notation, we write with 0x. So this is all about your address field. Next, enumerated data types. It also supports enumerated data types like here we can define enum a equal to, in the curly braces, you can write n number of values. Like bytes. Even bytes also, you can assign like this. Bytes 1, a equal to, suppose bytes 1, some name equal to a. means only one character. Bytes 2. Suppose if my string is only 8 characters, then you can write bytes 8. Suppose whenever we request for password, there are restrictions, no, for password only 8 characters. So since you are giving only 8 character, why should you allocate n number of, why should you allocate a string? You can go for bytes 8. Then it allocates only 8 bytes to your password. And here you can assign only, suppose if I have a bytes 2, some b2 equal to, if I try to assign 3 characters, then it gives me you will, while writing the program itself, while initializing the value itself, you will get an error. Next to function types. So here, like in JavaScript, we use it to write the function name as function. We use this keyword compulsorily. Function, function name, function, suppose function, see here, function, update marks of, function, update marks of, and here you should pass a number of variables, and then you should write the scope of the function, that is public, private, or something protected. Then you should also talk about whether it is internal or external. Internal, when you go for inheritance concept, these two concepts are used, internal and external. These are all optional. That is why I have given in braces. And again, pure or view for visibility, for accessing the variables, local variables and global variables. We use pure for local variables, view for global variables. And finally, we write public view, then we write returns. Returns of, you need to pass a number of variables, then we start the function and we close the function. In between, you have a number of statements. So I will show you the syntax here. So this is the simple denomination of your function. Now, instead of saying all these things, I'll just show you the program here. There you can understand everything. Now let's move to the Remix browser. Yes. So here, let's go to remix.ethereum.org. Sorry. remix.ethereum.org. So a new compiler will be open to you. Since I have already implemented some programs, those programs will be, displayed here. See, this is the environment of your Remix IDE. And this is how you can interact. This is your file explorer. This is for searching the files. This is your compile. This is for compilation. This is to run. In normal programming languages, we use it to call run, and here it is deploy. And this is to post to the Git debugger, and this is for Git, and this is for script configuration. Now let's see. These are for creating a new file, creating a new folder, and open a file from your file system, or uploading the entire folder, importing the files from IPFS, interplanetary file system, and importing files. And this is to your initializing the workspace in Git. Suppose here we go for contracts. And in contracts, let me open a small program like, for example, we work with some cube calculator. So now, what is the first statement here? I take SPDX license identifier, some MIT, or you can even specify unlicensed also, unlicensed. Next, I am running the program in 0.8.0 version. Now, my contract name is some cube calculator. So suppose here, I am writing contract cube calculator, and here I am writing this. You may get a doubt. Why I have written a function for this? Suppose I can declare a variable. Suppose I can declare a variable here. UINT. See here, when I type UINT, it is giving n number of denominations here. UINT 8, some 8, A equal to some 4. Here itself I am initializing the value. In other programming languages, what we do for this is UINT 8, some B equal to A into A into A into A. But, and suppose after doing these computations, you need to print those values. Here, we won't be having any kind of print statements here. We just use always return statement. By return itself, we print the entire document. See here, function cube, I am passing some number here. Here I have taken UINT 256. You simply take UINT 8 and I am passing some number variable, public. Here I have written only pure. Pure means pure function. It works only with local variables. Since I am working only with local variables. Suppose if I declare this one as a view, then you get some error. Means view function works with global variables or state variables. So public returns of, here see we are getting error. Why? Because I have forwarded the local variable as UINT 8 and here it is UINT 256. Once you declare function cube UINT n 8 number, public pure returns of UINT 8, then return. See, if you do not have pure, you will get some error, pure. Why? Because you are working with local variables. Compulsorily, you need to write. Pure function works only with the pure local variables. So here return number into number. And to execute this program, you see the beauty of this programming language. And here we have only, we have hardly four lines in this particular program. Once I compile this program, see here we have compiler version. Since I have checked auto compile, it is giving always compilation successful stage. You can select your compiler. See here a number of versions are there. You can select your compiler. Here already the default version is 0.8.26. It is a higher version compiler. But I am right, here I have used only 0.8.0. So no problem. If I write 0.8.27, then you will be getting error. Since it is a lower version, there won't be any problem. Since I have already auto compile check, therefore directly I am going to deploy. But before going to deploy, you just see, whenever you compile a program, according to our theoretical discussion, have shown you, it creates two types of files. One is your ABI and the other one is bytecode. Let's see what is this ABI. ABI is abstract binary interface, which acts like a bridge between your front end and back end, your back end and front end. Therefore, here I am copying this ABI. Let's see, I post it in some notepad. Let's see. This is in JSON format. So internal type UNT8 name, and you have one function that is cube. The type of variable, the state mutability is pure. And this is a function type. This is how JSON file will be created. Now let's go to another file. What is this bytecode? And while working with Java, we have seen several times a class file. But when you open that class file, you see some unreadable code like with some special characters and all. But here you see the exact bytecode of your Solidity program. See here, I am copying my bytecode. See, once you click here, it will be copied to the, your bytecode will be copied. And here I am pasting my bytecode. See, this is the exact, here you can see the beauty of Solidity programming language. Of course, it is in hexadecimal notation. If I write with bytecode 0101, it creates so much amount of line. I mean, it is a huge line. That is why they have represented in hexadecimal notation. Now we use it to teach our students, like JVM executes your bytecode, it converts to machine code or assembly language. This is how we use it to teach our students. Now I will also show you how your assembly language program looks like. Now here we have, you can go to bytecode to opcode generator, etherscan.io. Here we have some opcode tool. So here, go here. We have ether contract bytecode. Just paste your, see here. As I have explained you earlier, this is in hexadecimal notation. That is why only 0x. Though it is a bytecode, I am not writing in zeros and one. Those zeros and ones are represented in the form of hexadecimal notation. So just paste it here. So as soon as you press, as soon as you paste here, you just go to submit. How many number of lines that your program has? It has only 4 lines. See here, for 4 lines, this is generating a bytecode. See here, our assembly language program push. Since I have I'm taking one local variable and I am returning that I am taking 2 registers. 0x80, 0x40, I am storing the value, I am calling the function, loop1 is 0, jump statement. See here, for 4 lines of code, we have 293 lines of opcode, assembly language code. So this is how you have, you can see your exact bytecode of any program and ABI format of your particular program. This is a small program. Just to explain you, I have taken a small program. Let's go to the, for example, to know much about your, let's know how do we execute. Of course, it is an IDE, browser-based IDE. Once you go to deploy button, here you have, it is taking Remix VM Cancan, virtual machine, Remix virtual machine Cancan. If you take injected provider MetaMask, see, whenever I click this one, immediately it will connect to my MetaMask wallet. It will connect to my MetaMask wallet. But here I am working with Remix VM only. Then, see, this is my account address. This is the contract created account. We have there are 2 types of accounts, externally owned account and contract account. No? So your contract has created this account. See, here we have how many accounts? Nearly 10 accounts. Each account has 100 fake ethers, 100 test ethers. Each account has 100 test ethers or 100 fake ethers. Now I am executing my program using this. This is about your gas. This much amount of gas you need to pay. So once I deploy, so see the contract name, Cube Calculator. Once I click this deploy button, what happens? You see here, contract was executed using this address and the hash transaction hash value is so and so. Block hash, and this program was executed on so and so time. Block hash. Now my block number, sorry, 1 minute. My block number is 26. Why? Because I'm executing so many programs from, that is why my block number is 26. And this is my contract address from and to. How much amount of gas is deducted from your transaction cost, execution cost, and input variables and output variable. Now, let's see. Once you deploy this one, here you will get deployed contract. See here, Cube Calculator was deployed at so and so address. So just expand it, then you will get something like this. Why? Because your function has some input. Therefore, you should pass some variable, some parameter, some value here. That is uint8. That is I'm giving some 5. So now the function will be enabled. Whenever you click this cube, you will be getting 5 cube value, that is 125. You see here under the logs also, you are getting the value. See, this is how your program will be executed. Now, this is your interface. Who has created this GUI? We have not created, no? Automatically, this IDE, it has see, when I execute this program, you can see when I expand this artifacts, you can see the related JSON file. And once you go to scripts, you can see the ether.js and web3.js files using which a small interface has been developed for you, and they are showing here. You need not develop. Suppose if you want to develop an interface, then you can go to your React.js, and there you can develop an interface for this particular application. So this is all about a small program. I will show you 2 more programs since we can't work with everything. If possible, if the time permits, some other day I will explain everything. For example, you see here, state variable. From the morning, I use it to talk state variables and local variables. No, if once you declare the state variable, here I have declared 2 global variables. Global variables are itself state variables. So declared 2 global variables. See here, I am trying to modify my state variable, which is a equal to 10 as a equal to 20. When I want to update like this directly, since I'm accessing global variable, it is view. It is not permitting me, see, a number of errors are there. It is not permitting me to update the values. If you want to really update, you can write a function without having any view or pure. Without having any view or pure, you can write a function and you can update this 10 value 10 with your underscore a. This is how you can work with your state variables. Like let us see data types. Here you have a number of data types like uint8, a equal to 20, b10, bytes data type. See here I have 2 characters. That is why I have assigned 2 bytes memory space. Next you have string name ABC. uint of, this is how we declare a static array. This is not a dynamic array. Suppose if I want to print all these values, here you don't find any print functions. You can directly see I am writing a function. You can see another beauty of this programming language. Here we are writing the function, but I am not calling any function here. Am I calling any function? See, even if I write, it shows some error. You need not call the functions. These functions are self-executable function. That is why these programs are self-executable contracts. Now function printf public view. Why I'm writing view? I'm accessing all the global variables, all the state variables. Returns how many variables I am returning? One is primitive data type uint, another primitive data type, and two reference data types like string and array. And to access a string and arrays, when you declare them as global, but when you want to access in a local function, then you will not be permitted. Suppose if I write only string, you will get some error. String. Why? Because you need to write memory keyword, string memory. Then they are going to be stored in blockchain. So always global variables are stored in permanent blockchain. Local variables are not stored in the blockchain. uint8 array also memory. Similarly, bytes too. This is a primitive data type. That is why I have not written any memory keyword. So here I have written of a comma b comma name array, and B1. See, when I go for deployment, here you have data type demo. And when you click this print, it prints all the number of values, whichever you have taken. See, wherever I have written bytes, it gives me the 2 characters byte values, 68 and 69. So the ASCII values of these 2 characters. Now, let's go to a simple smart contract. What I want to show you here. So even in array sorter also, after writing the entire code, you need not write again for loop to print your array. Simply you can return your array. You can return your array name. And another one is, okay. See here, string comparisons. In the other programming languages, we use it to compare strings using pattern matching, or we compare each and every character with the from string 1 to string 2. But here you can use directly a hash algorithm. Here we use KACAC 256. Why? Because for each and every string you can calculate the hash value. String 1 hash value and string 2 hash value. And these two strings hash value can be calculated, and we compare only those hashes. So therefore here in a local function, I am taking str1 and str2. These are the 2 strings. Since I am working with local variables, it is pure and it is returning bool. That is either true or false, equal or not equal. Therefore, see here return KACAC 256, or you can even write SHA-256. KACAC 256 of ABI.encode packet of str1, which is equal to KACAC 256 of ABI encode packet of str2. See, when I execute this program, go to the deploy. I am not compiling. Why? Because here I have auto compile version. So go to the deploy. Once you compile, you will be getting like this. Pass 2 strings here, like hello and hello. Of course, these 2 are same names, but according to the hash values, they give 2 different hash values. Therefore, it gives, when you write when you execute or when you call this function, it gives false. Why? Because we are comparing the hash values. If I write h, then again call this function true. So here itself we can call true. It is showing the previous one. Don't confuse with this. And another one on the same strings, string concatenation. Even for string concatenation also, we don't use a concat statement here. We use the string ABI dot encode packet of str1 comma str2. This is how we convert their string values, str1 and str2. So this is how we combine 2 different strings together. For example, coming to the structures, here also we have a keyword by name to combine different data type values. You can have structure, struct person. Always we start program with contract, like we start our program with class keyword in Java. Here we use contract keyword. Of course, you need not specify public class, private class, protected class. Here you need not specify public keyword. You can directly use contract. And why? Because the contract is public. Now, we are creating an object to the person and we are writing a constructor here. We are, sending the values and we are displaying the values. For example, I will show you to show a simple, see here, I have written some student structure where I have roll number, name and marks in 5 different subjects. And the entire structure is mapped to some address here, student records. And here each and every student will be having some address. And I'm writing a modifier function, which function, wherever I write only teacher can only update the marks or teacher can only add the marks. So this is only the teacher can perform this action. So for example, see function add record of. This is after passing all the variables, public keyword, I am writing only teacher. Means this function can be executed by only subject teacher or something else. Whereas get record, this can be viewed by anyone. Therefore, I am not writing any only teacher function. I am not writing any modifier. Modifier is a reusability one where each and every time without writing all this code, you can simply use only teacher keyword. To delete record, who will be having privilege? Only the teacher can delete the record. So only teacher require of, and here we have three functions. One is adding the marks, adding the record, student record, getting the student record, and deleting the student record. Suppose if I go to a function, let us create two different students here. For example, this is all. Here see n number of statements we have. If you forget those orders, just elaborate it. Here you can add the address, student address. See, the first address is our contract. Whenever I execute a program, your amount of ethers are going to be deducted. So this is my first student address. Let me copy this one and paste it here. And I have to change this address to contract address. This is the one. See, and here I am trying to add the student name, roll number 101, name, some hi, some marks. Here I am adding an array. Suppose 78, 89, 98, some 90, 3, 4, 67, something like this. And just use a transact button. Then to see the record of a student, you should copy the same address value and you need to paste the student address. Then you will be getting the student information. And this, whenever you click teacher, you will be getting the teacher address. Suppose here, see the teacher address is contract address 0x5b3. And suppose I want to add another student here. I want to add another student. Who can add the student? Only teacher can add the student. See here, this is my second student address. I am copying this address, but I am not changing it to contract address, teacher address. I am leaving this one for a teacher address itself. Sorry, student address itself. So now I copy here. See, he see here, you have all the functions are executed. Whenever I call, you have your functions are executed. Now this is 102 and here something else. And let us take the same marks. And when I click a transact button, see, you are getting an error. Why? Because transact to student management system add record error occurred. It has reverted. The transaction has been reverted to the initial state. Why? Because only the teacher can perform this action. Student records can be added by class teacher only. So see, I have not written a number of codes for user and administrative. I have written the same program, but using a single reusability function modifier. I am declaring the function access. You can give privileges to different people who can access your function, who can execute. Though it is a single, he can execute, student can execute this program, but he cannot execute a particular function. See, now we are in student, same thing now, but student can get the record. Any doubts? Since we have a limited amount of time, I couldn't explain you the entire Solidity programming language. Just I have given an idea on Solidity programming language and how do you execute your smart contracts. Since you are giving privileges to each and every function, though it is a single program, though it is a single contract, you can assign function privileges also. Not only a teacher, here you can write only teacher, only principal, only COE. This is how you can implement your functions. That is why it has a lot of security in blockchain networks also. Any questions from the participant side? I will share you all the links and everything to you. Any doubts? Yeah. Okay. Already our resource person has joined. Sir Nagbab sir.
Yes, madam.
Okay.
Yeah, thank you, madam. I would like to extend my heartfelt gratitude to Dr. Kalavathi, madam, for delivering such an insightful and comprehensive session on building smart contracts in Ethereum blockchain. Thank you, madam. Thank you for sharing your valuable knowledge and for being part of this faculty development program.